Hi friends, myself Aniket Vishnu Renavikar, Assistant Professor, Center for Distance Education, Shivaji University, Kolhapur. Today we learn the subject about types of machinery and types of structure. Already we seen the walls and machineries which are used for the various building materials. Next part is that we can see the types of machinery. There are various types of machinery. First is the stone machinery, brick machinery, composite machinery, concrete block machinery, compressed earth block machinery, and glass blocks. So there are various types. There are various functions of this. In this stone machinery, there are two types of it. The first is a random rubber machinery, and the second is a ashlar machinery. In this random rubber machinery, the stones of irregular sizes and shapes are used. So these stones are arranged so as to have a good appearance. If the face stones are chisel dressed and the thickness of mortar joints does not exceed 6 mm, it is called as a random rubber machinery. And second type is a ashlar block coarse machinery. In this occupies the intermediate position between the rubber machinery and the ashlar machinery. The faces of the stones are generally hammered, dressed, and the thickness of the mortar joint does not exceed 6 mm. This depth of courses varies from 20 cm to 30 cm. This type of construction are used for heavy construction work such as remaining walls, sea walls, etc. And in some cases, it may also adapted for theatres, railway stations, temples, bridges, public buildings, etc. Next part is ashlar facing. Ashlar facing machinery is provided along with brick or concrete rock machinery to give better appearance. The sides and beds of each block are properly dressed so as to make them true to shape. The exposed faces of the stone as rough tooled and chamfered. The backing of the wall may be made in brick machinery. These are the types of the stone machinery. Next is a brick machinery, which we can use the bricks for the art. Next is a composite machinery. In this we can use brick and stone are composite material. Concrete blocks, compressed earth block. These are the various types of the machinery. Next part is a types of structure. There are various types of structure we can see already. We can see in this. The first is a load bearing construction or load bearing structure. To start with actual planning and design, the following information should be collected in this is vary from location to location. First is a occupation, climate, soil strata, local material available, size, social economic status, and availability of space. The first step is functional design of the building, which is very particular in rural lifestyle and is based on the socio-economics and cultural characteristics and need. There is since privacy is not a prime thing in rural areas, houses usually offer into living cum bedroom. Good combination of indoor and outdoor spaces is done in planning, which reflects the vibrant activities. Their interaction of rural lifestyle. House is divided into two parts, front yard and backyard. The various detailed spaces in there, these are as follows. For front yard, there is a veranda, cattle shed, grain store, courtyard, living room, etc. And backyard, kitchen, sanitary unit, washing area, cattle shed, fuel store, bed space, etc. After detailed case study of lifestyle of rural area, these types are designed, and these which are usually in a rural area. We can see in this there is we can entry in the veranda, then we can go to the living room, or there is a more houses in the veranda and living is in same. In that the back the kitchen is available, and that kitchen there is a toilet or sanitary unit is for that toilet or bathroom, and next to there is a bedroom. This is the arrangement of the buildings in rural area. For this, in load bearing construction, soil strata and superstructure walls play important role. Load of the roof transferred to walls and then to foundation and ground. Sometimes limitations are there on room size. We can design short span up to 4 meter with divisions in long span at appropriate location. This is the load bearing structures. Next part is a framed structure or framed construction. We have RCC steel and timber frame structure in practice, but RCC frame structures are widely used in house construction. So we will concentrate on its properties. As RCC is of ductile nature, preferably and widely used in earthquake resistance material. Architects and engineers have more freedom in design with various properties of this material. Composite structures with combination of load bearing and RCC is also possible. All these materials have IS code for seismic safety design. Frame structures are safer and stronger in earthquake resistance, but this can be achieved with good quality construction. In frame structure, simple regular forms of house planning are safer. Square, rectangular, circular forms and combination are preferable as per the IS codes. The forms of house design will vary as important points. First is occupation, family size, socio-economical status, availability of spaces, climate, soil strata, local material is the very important for this. The functional design along with socio-economical and cultural characteristics of the family is a primary step for any architectural planning. Standardized forms are low income group, middle income group and high income group for this. Next is this is the further classified on the built up areas up to 40 meter square, 40 to 100 meter square or more than 100 meter square. These built up areas for each category will guide for number of spaces and activities. As per the urban lifestyle, some spaces may be added in this as balcony, sit outs, terraces, porch, utility, etc. All these spaces are designed as per the availability of space and prime importance is given for privacy or individually. Selection of building material and finishes and techniques will add for aesthetic and visual features of house. For this, IS 13920, IS 456, IS 1893 part 1st can be referred for RCC framed structure design. Selection of building material and design of foundation can be done as per the IS code. Seismic safety, design, structural configuration of building should be done at the time of approval of building plan and got assessed by the local authority. Next point is a composite structure. Type of the structure is a composite structure. These are the combination of load bearing and frame structure as per the requirement of user and space design. Normally, cantilevered portion like porch, balcony, chacha, etc. are constructed in RCC frame. Sometimes steel structure are also combined with RCC frame structure. And anyhow, it is different material are used. Ultimate strength and stability should be achieved by designers. So, composite structure, there are various types of the structure are used in here. Next is a part of the structure is a temporary structure. Temporary structures are designed and built up for very short stay at different projects of construction or rehabilitation of site of disaster. Normally, very lightweight building material like GI sheet, AC sheets, steel frames, wooden planks, plywood, etc. used. These can be constructed with bolting, welding or nailing and screwing at the required stages. This can be dismantled and used for next activities very easily. Sometimes temporary foundation and plinths are also constructed with brick concrete block having low strain mortar in superstructure. These temporary structures are used in contractors for the various locations. For the first, we can see there is a one building which duration for completion is 2 years. We can provide this for the cement go down or the watchman's cabin for that. provide with it. Then these 2 years we can after 2 years we can dismantle this, and we can going to the another side of this, or we can use this part in another building location. So this is the temporary structure. Next is a plinth structure. This is the portion of a structure between the surface of surrounding ground and surface of the floor, immediately above the ground. The thickness of the plinth wall depends upon the weight of the superstructure and the width of the foundation concrete. In case of a deep foundation, the stepped wall for the plinth is provided to increase the lateral stability through the provision of extra depth of earth filling. For this, as per the bylaws, the minimum height of the plinth should not be less than 45 cm, and plinth wall should be made solid, usually 1:3:6 mixed concrete. Concrete grade of concrete is 1:3:6. The plinth height depends upon the various factors such as need of architectural treatment to a building, highest flood level of area, adjoining groin nature, etc. For this, basic requirement of this is plinth wall should be satisfy the following requirement: to transmit the load of superstructure to the foundation, to act as a retaining wall so as to keep the filling in position below the raised floor, to protect the building from damp or moisture penetration into it. This increases the stability and durability of the structure. It enhances the architectural appearance of the building. Sometimes we require different levels of or platforms for different activities. There are usually in public places like playground, schools, gardens, footpaths, platforms, stage and industrial building. Foundation as per design are made and masonry walls are constructed up to plinth level. Plinths are filled with rubble or murum or finished with concrete or floor tiles as per the requirement. Sometimes temporary steel or timber structure is also designed as per the requirement of the plinth. Next part is the superstructure. Superstructure is the various types of walls, includes various types of walls, various classification, construction details of brick, stone, block, masonry, etc., which is also we are already seen in this brick, stone, and block masonry. For this, so every building consists of two basic components: the superstructure and substructure or foundations. Superstructure is usually the part of the building which is above the ground and which is serves the purpose of intended use. Substructure or foundation is the lower portion of the building, usually located below the ground, which transmit the load of superstructure to the substrate. Superstructure consists of flooring, masonry, doors, windows, lintels, stairs, slab, etc. of this. So these are the various types of the structures which we have seen in this. So today we stop here. We have you have to any query or any doubt regarding this, you can contact me on following mail ID: cd_multi@unishivaji.ac.in. Thank you very much all of you. Thank you.